So Miniscript and descriptor, it is a technical topic, in fact, deep technical topic into Bitcoin specific stuff. So it might be more useful for people who are already familiar with these three terms. One is BIP32 spec, the another one is Bitcoin scripts, and the general idea about what is Bitcoin wallet. If you are familiar with these topics, little bit of technical understanding, then this will be more useful to you. Otherwise, it will be a gibberish. Just ignore me.
Show of hand if someone is not familiar with something and like explain in one line what that term.
Okay. So based on what I just said, and any of you say, is this completely new to you or raise your hands? Sorry? Explain it once. Okay. Anybody else who has? Okay. Okay. If you are completely from non-technical background, I can't help you. Save yourself. Don't ask me anything to explain further. And this is a new topic for me as well. So if I lie something, if I make up something, people who know this, don't interrupt me. Okay, now get into the topic. So myself, Saravanan Mani, I work at Bitgo as a senior software engineer for BTC team. It is 6 people team within Bitgo company. I'm one of the engineer working from India. So let's get into it. Definitely, we are hosting the event, right? Definitely, we will shield our company. Please bear with us. So, Bitgo recently decided to explore descriptor and miniscript, whether it can be useful for Bitgo as a company to provide better products. So, this is what it is. In general, Bitgo supports 2 of 3 multi-sig wallets, right? Any 2 signatures out of these 3: user key, backup key, Bitgo key. Mostly non-custodial wallets, and we also support custodial wallets as well. So either of these 2 keys will be able to spend your coins. That's the basic idea, the Bitcoin ecosystem. It's tightly coupled with this kind of wallet from the very beginning. So what descriptor and miniscript will enable is any arbitrary Bitcoin scripts with any kind of conditions, spending conditions, which involves any number of keys, and the hash locks like SHA-256, hash 160, any kind of hash locks that is supported by the Bitcoin scripts already, that can be spent also, and time locks as well. So if you want to spend your Bitcoin with this key plus after this number of blocks or after this particular date, that can be supported with the arbitrary Bitcoin scripts. But the problem with arbitrary Bitcoin scripts, we have some problems, we will get into that. Because of those problems, it is not easy to incorporate into any wallet platform. But if we bring descriptor and miniscript into Bitgo, we'll be able to support any arbitrary script with this kind of locks, so that we will be the superior in our industry. Nobody can beat us. That is the idea. So, next one. First, this will involve few slides, and then we'll get into the actual demo as well. It will involve some coding. So what is miniscript? Before we get into the miniscript, we first look into the problem points that miniscript tries to solve. First, we need to look into the Bitcoin script. For those who asked what is Bitcoin script in the beginning. So Bitcoin script is a kind of a programming language in a simple way, but it has very limited capabilities to do limited stuff intentionally, so that it cannot screw things. So it's a stack-based language. I think it is based on Fortran programming language, very age-old programming language. So it is very hard to work with. It looks like kind of assembly level programming when you work with Bitcoin scripts. We will see some examples. So usually, to easily summarize, Bitcoin scripts are nothing but it involves these 3 locks. As I said, signatures, using signatures, I mean using your private key, you can spend your Bitcoin. Or using some hash, like 256 hash or something like that, you can unlock your Bitcoin. And the time locks that I mentioned. Any of these 3 combinations at any number of combinations with some limited bounds are there. Usually Bitcoin scripts are composed, and a stack is involved to run this program. That is a basic idea. So we'll look into the script that Bitgo already uses, and this is the standard one everybody uses in the industry. The 2 of 3 multisig, any 2 keys can open it. So this is the actual Bitcoin script, Bitcoin script itself. So it simply says, any two keys out of these three do the multisig. So it understands the message here, and to unlock this script, it is a locking script. We can call it as a locking script. Okay, it locks your Bitcoin with these public keys. You can lock your Bitcoin. To unlock this, any of these two combinations has to be fed here. Usually, this is copy pasted and put here. This whole thing is fed into the stacks that I mentioned. So the stack will be able to run it, and it will finally, if it says true, I mean, it is a valid unlocking script for this script, then your Bitcoin is spent. Okay, so that is the basic idea about the Bitcoin script itself. But it looks very simple, kind of easy, right? But that is not the case in reality. It has some challenges. These are all the challenges with the Bitcoin scripts. Some of them I copy pasted without any self-respect from Miniscript web page and improved a little bit, very little bit. You can see the same in the links that I'm going to share. So these are all the main 7 points that I see. One is, as I said, the Bitcoin script is nothing but a spending conditions, bunch of spending conditions, or conditions, or under conditions, something like that, involving the locks that I mentioned. If you are given a Bitcoin script, it is very hard to deduce what kind of spending condition it permits. Because if you see a complex Bitcoin script, you will understand. I will show it to you. That is one problem. The another one is, even if I give you the private keys that can unlock the Bitcoin script, how to create your witness that can easily satisfy your Bitcoin locking script. That is also is not easy to do. And the predicting the cost of the price of your Bitcoin script upfront is not an easy thing to do. The other one is yeah. So I said something about the boundary, right? Bitcoin scripts is very limited. It has some boundaries. It cannot have more number of commands, more number of data. It has some limitations, various number of rules and regulations. So it is very hard to capture that upfront when you write your Bitcoin script. It's very, very hard thing to do. The fifth problem is combination of spending condition. Yeah, it's a bunch of spending conditions, right? Which one is the most economical spending condition given a Bitcoin script? That identification is not easy thing to do. And implements a yeah. If you have a Bitcoin script and if you want to replace one of the condition with another totally different condition, that is not something you can easily go and directly change it. It is not easy thing to do. And finally, writing a bug-free complex Bitcoin script is not at all a thing that we can do. It's very, very tough to achieve. Usually there are very big brain folks in Bitcoin industry. They are the ones who these kind of complex scripts are sent to, usually the big blockchain kind of entities. They review it once that level of auditing is required here. So these are all the problems to get some gist. Here is our savior. So Miniscript is going to solve those problems by introducing some abstract level programming language. If you are familiar with JavaScript, you know about TypeScript. TypeScript solves some of the problems associated with the JavaScript, right? Something similar to that, but not exactly like that, but to get some idea. So it's a language. I had some beeps out here. I don't know whether it is lost or not. Yeah. Okay. So, but anyway, please check if there is a way to check it, please. So, Bitcoin scripts, it's almost unbounded conditions you can write. The thing is, Miniscript is a way you can write a subset of most number of a bigger subset of Bitcoin scripts you can write using the Miniscript that will solve the problems that I mentioned. Using Miniscript, it is very easy to statically analyze your the properties, like which spending conditions is the most economical one, what spending conditions are supported, is it a valid Bitcoin script which matches of the node that is going to validate it, and the security properties that you the malleability means after you produce your witness, if somebody can change your witness, but still the witness is valid, that is a malleability. Because of that kind of activity you do, that will cause a lot of problems, including the high fees and the other problems. So it has to be non-malleable. It should not be changeable after the signature is done, witness is produced. So that is the idea. So Miniscript version of the same 2 of 3 we are seeing here looks simpler. Multi 2 of these three keys we are given here, but still we are not convinced. Okay, almost same, that not giving that much advantage. Let's get into the complex example. It's an dummy example that I came up with. Let's say that it's a Bitcoin script that we want to write. Here we have totally 4 keys: CEO, CFO, CTO, and CEO of the company, let's say. And we want 3 spending conditions. First one is after 1,000 blocks, CEO alone can spend the Bitcoin. Then the second condition is any of these 3 folks can uh, sign before 19th of April, or any of these 2 folks can, sorry, any of these, out of these 3, any of 2 folks can spend the same script after 19th April. So let's say this is the condition that the party wants to write with the Bitcoin script. Okay, let's say that is the case. And meanwhile, if you have any unclarity on the topics that I'm sharing, please let me know in the middle. We can discuss about it a little bit. Okay. Yeah. Look at the miniscript version. Look at the Bitcoin script version. Definitely not pleasing pleasing script, right? It's too complex, too much things. It's very hard to analyze, understand things, those things. But let's first focus on this. The miniscript version. It simply says, and I mean these two, CEO and after the 1,000 blocks, or a threshold of these 4, 3 out of these 4, these 3 keys, and it says after this 19th April 2024 is mentioned here. That's what is mentioned here in terms of some number, block number. So it's a miniscript version. The same, it will produce this Bitcoin script. Let's not get into this. It will take time. Okay, but that's what is given here. This is the only thing that a node can understand. Let's be clear on that. A Bitcoin node cannot understand this language. A Bitcoin node has wallet component. That wallet can understand it, but a node, when it runs the stacks, those things, it doesn't make sense to it. Only these things that can be understood by the node. Similar to only Java V8 engine can understand JavaScript, not the TypeScript. The same thing. Okay. Yeah.
So quick Q&A. In the meanwhile, I'll check.
You want to check? Yeah, check it.
You can do a quick Q&A.
Q&A. Okay. Meanwhile, if you have any questions, we can discuss so far. Just to pass the time. Anything. Limitations of miniscript. Yeah, one thing I already mentioned, it's only supports subset of Bitcoin script. If you have a more, I think Lightning channel cannot be implemented in miniscript because of some reasons which I'm not very familiar with. If you have more complex Bitcoin scripts which involve certain conditions which I don't know, some subset only can be written with miniscript. Not every Bitcoin script that you can write with miniscript. That's not the case with the TypeScript, right? Any valid JavaScript program you can write in the TypeScript. That's another case here. But mostly you will be satisfied. We are not going to do that level of rocket science. It's not going to happen. That's one thing. Another thing is another tool that we need to bring into the Bitcoin ecosystem. We all know that Bitcoin is very adamant to bring anything new into the ecosystem. So it involves, so you cannot see the adoption in the market. Like Bitgo is considered, Bitgo is one of the company. We can probably say that always try to do the cutting edge technology as soon as possible. They brought Musig to PSBTs, anything that you see, they try to bring it as soon as possible. Taproot, in fact, before even Taproot is launched, Bitgo was ready with the Taproot, and almost the same day they launched the Taproot wallet. That kind of commitment that this company has. But we are considering the miniscript all this time. After this time, I think it came 1 year back, 2 years back, something. Sorry.
2019 or 20.
Yeah, we are also too slow when it comes to this because adoption is too low. So you cannot see the fellow cosigners who are using the miniscript. That is one another problem. Technically, I don't think so much. This kind of limitation. Maybe I'm missing something. If anybody else knows, please back me up. Limitations of miniscript.
Limitations of miniscript. Like there's only so much you can do with the miniscript. Like writing raw script, you can has endless possibilities. But miniscript semantics are fixed, so that can be considered one of the limitations. I think another limitation is all the opcodes are not allowed in miniscript. So some of the opcodes have been kept out of miniscripts. Yeah.
What Bitdevs is solving? Robin Linus.
Sorry, sorry?
Bitdevs, virtual machine.
It's completely not aligned with this now. We will discuss about after Q&A something like that. Yeah, okay. It's different topic. Yeah. Sorry?
Bitdevs is trying to be more expansive.
Oh, that relationship. Yeah, it's more expensive, and Bitdevs is going to be Turing complete. ready using some loopholes that we have, not loopholes, some tricky ways to achieve Turing complete on top of Bitcoin, scripting language, not scripting language actually, the taproot scripts, Merkle tree and other stuffs. In short, it's Turing complete support, but it is not production ready, nowhere close to test ready. It is a theory that we have.
It will take time.
Economically, it is not feasible as of now. Maybe we need more R&D to make it more economic sense. Yeah. Any other questions?
And basic question, so is Miniscript primarily for Bitcoin developers or is it something that can be used by end users?
It's for developers, primarily for wallet developers, I would say, Bitcoin wallet developers. But how it impacts the end user? That's a good question. How it impacts the end user? So if you have a hardware wallet, you want to set up a complex setup. I've shown up some dummy version of thing, right? So with hardware wallets or any market standard wallets which supports Miniscript, they can easily uh, uh, ask a developer to create a Miniscript and they can start using the wallet setup, new kind of wallet setup where I want 5 signers, 2 hash locks, 1 time locks, those things. It enables a user to use the existing tools in the market and come up with the last complex spending conditions that their business requirement require. That is the kind of impact that user can have. Because hardware wallets, there are wallets that can support Miniscript out of the box. So you can simply share this in a different format. That wallet will immediately able to spend, monitor those kind of things.
So it's like, what's the primary use case?
Sorry?
Why was it created to solve this big problem?
Those 7 problems, like those are all those.
Those are like the pain points of the script. Because it cannot do everything. Was it like developed with multisig in mind or any?
Not just multisig in mind, general Bitcoin scripts in mind. With these 3 hash lock, time locks, and signature locks, those things in the mind. So those to resolve the pain points only, that is the main reason. I don't think that there is much else. That is the main reason it brought into the idea.
Well, it's mainly syntactic sugar.
It's a syntactic sugar. Yeah, that's a right way to put.
That's what makes it.
So are there any
Scripts can you do a 2 of 3 with one of them being a 3 of 4?
Yeah, sorry, that's a good point that she brought up. So one another thing is, let's say that let's say that let's say that you want to replace this key, okay, with another multisig. Okay, instead of one single key, you want this particular spending condition as another multiscript. If I ask to do the same here, you will quit the job. Okay, wow. But here it is easy to, very easy to do. That is one another technical advantage that we have with Miniscript.
AI can do that.
Sorry? Don't talk about AI here. We don't talk about AI here. No.
So it's never going to be pushed into the Bitcoin core, right?
It is in Bitcoin Core, but Bitcoin Core has multiple models, right? The stacks, the program running, the Bitcoin script running model, the actual validation of your transaction, those things. The another one is wallet. Bitcoin Core comes up with a wallet natively. That wallet supports this out of the box. So for your question, yes, Bitcoin Core supports Miniscript. Yeah.
So the standardized public key, standardized digital signature. Would it be correct to say that what a Miniscript is doing is it's trying to standardize Bitcoin scripts, facilitate better interaction between multiple wallets?
Eventually that will happen, but I wouldn't say that is the goal intentionally they had meant. Or I don't know. That could be the reason. Right answer.
Is that like the way Bitcoin script is massive, now Miniscript makes it so concise. Does that have an impact on the transaction fee? The transaction size now?
Yeah. It is smart enough to, I mean, to stop you from screwing your own Bitcoin script. I mean, if I give you a spending condition, the way that you write the possibility of you come up with the Bitcoin script which unnecessarily has more opcodes, so the more fees probably is higher. It's high, right? But if you use Miniscript, since the surface is very limited, the primitives are very limited, you making the mistake is very contained. I would say that. So the more standardization may happen if more wallets, yeah.
So like heuristically, the Miniscript that comes and answers a certain required script is optimized for like
like payment. It's optimized for how much it's going to cost. In terms of bytes, it's the most optimized.
Yeah.
But is it proven that there's no other script which can be written, which is going to be less expensive than the one
That no, I think it's up to the developer's capability. He may come up with a better Bitcoin script that is more optimized than
And even
Bitcoin.
then,
But
it's like opcodes are very small. The main size is coming from the keys and all that. The opcode, how much more are you going to get?
But the idea of Miniscript was that it will give you somewhat optimized,
Safer.
safer and optimized, non-malleable, those kind of things. Yeah, it's like this. If there are some developers who wants to find out is it an even or odd number, they may write 1,000 pages of code to just find out that. And there are one line code change that you can usually find, and there are more optimized bit operations to find out. Simply check the last 0 or 1. There are multiple ways, right? Miniscript is kind of more engineered to the most optimal solution as much as possible, but nothing can be perfect. Okay, it's up to, if developer is more smarter than Miniscript, he will definitely, especially the people who created it, obviously he knows more than Miniscript, right? That's why he created this whole thing. So it's up to the developer, the short answer. Okay, time is over. Okay, all we talked about some magics with the Miniscript does this and does that, those kind of things, but how it is possible, how Miniscript achieve this, what is the intuition, the actual rules and regulations, how it works, it's kind of translation. Take this, in reality, it has equivalent, not for this, it has equivalent Bitcoin script mapping in a table, those kind of things. And there are some rules to achieve all those securities, correctness properties and everything. That is a reality, but we don't want to get into that. Again, it will take a lot of time. So this is a completely different analogy to explain how it works really, I mean how it achieves this. So if you are familiar with postfix notation, the how you represent your arithmetic operations in computer programming, this is the postfix notation from some random the same this is a random arithmetic operation. It has nothing to do with Miniscript, Bitcoin or anything. I'm just talking a totally different thing, just to get to explain how it works. So for this equation, this is the postfix notation. Okay, let's say this is the one that computer can understand. That usually postfix are prefix only computer uses to process the operation, right? Arithmetic operation. It takes A and B, put it in a stack, then it sees plus, take B, A, add it, put it in the stack, then look, take C, then last two data, do the multiplication. That's how it works usually. It is easy to computer to understand, but it is very tough to analyze this. But this is more easy to analyze because we have strong rules here. We are saying that it itself is an arithmetic operation. We are comparing it here, right? And again, we are comparing here. We are not giving the operator precedence to decide on this. We are explicitly forcing the developer to put these brackets here in our dummy version of Miniscript kind of idea. So here it is very easy to analyze. I can verify if it is wrong. I would simply say this is invalid script. If this is not a valid arithmetic operation, we can reject it. It is very hard to do that here. And I'm enforcing some arbitrary rules here. If you have any number that ends with a decimal, if it ends with zeros, strip the zeros. I don't want the zeros for economical reasons, for some rules, some constraints, right? So I'm enforcing that. And if you have constant in this kind of division operation, let's do the division by yourself and put the actual data here because you already know the data. I'm just enforcing some rules here. So this is more easy to analyze, come up with the solutions, how it can be solved, those kind of things. It is not the case with here. Something like this Miniscript does. It just transpiles the Bitcoin scripts in a different way with bunch of rules that meets these criteria. Just for the intuition purpose, please don't confuse it with the actual Miniscript at all. Okay? Any questions here?
This is given because Bitcoin's it's like a postfix notation.
In a way, yes. Yeah. In a oversimplified way, yes. Okay. Yeah, we are done with the Miniscript theory. Now moving into the descriptor theory. Okay. Let's now forget completely about the Miniscript. Let's not confuse temporarily about the Miniscript with the next few slides. Okay. It's a totally different topic. That's how we have to see as of now. So what is descriptor? It is another thing. But before we talk about the descriptor, let's talk about the area that descriptor comes into the play. The area is Bitcoin wallet. what is Bitcoin wallet? Wallet is simply, it does two operations: receive your Bitcoin, send your Bitcoin. That's it. That's a primary role of wallet, right? How do you usually receive your Bitcoin? You create your locking script like we discussed, using the spending conditions, using public keys, hashes, time units, depends on your requirement. And using this script, we create the address out of this script. That's how address is created and shared with the sender. So that is how we receive Bitcoin. How we send Bitcoin? There are some steps involved. First, we get the output address and the amount that needs to be spent, and yeah, the amount that the UTXOs that we are going to use to spend the Bitcoin from, and create the address. The same two steps here: create it and check with some kind of indexer or block explorer to fetch the UTXOs that matches this address. Now we have the UTXOs to spend with, which matches these amounts. And now then what do we do? Then we start building the transaction by adding these UTXOs as inputs. Then we add the locking scripts, unlocking scripts. Then finally we build that, add the witness, finalize the Bitcoin transaction. Then we broadcast it, done. So these are all the major steps, oversimplified format. Okay. So receive and send. The challenges. There are many challenges, but we are highlighting only two here. If your Bitcoin script is not very popular one, like 2 of 3 or single sig or 2 of 2, those kind of things, there is it is very hard to bring the cosigners into the wallet. If you want, let's say, a Bitcoin script that we shown in our previous example, if I want an hardware wallet to support that, there is no way that I can communicate to that hardware wallet. This is my script, Bitcoin script. Please understand this. It is not easy to do that. Maybe you come up with some proprietary solution, but it is not possible. That is one thing. So we need to use some template, proprietary template format to represent your Bitcoin script in, so that you can share with your cosigners, so they can validate the locking script by themselves. The another one is the same point. So that is the main important points, I would say. So again, another savior, descriptor. For now, forget about the miniscript. If you see anything related to the miniscript, don't confuse with the miniscript. So 2 of 3 multisig. For this is the descriptor. So it says segwit type, multisig wallet, 2, 3 keys, and the expub details. Somebody asked about the expub. What is, I mean, BIP32. BIP32 is nothing but represent your key data in a way that it can derive the derived keys easily, and it can be shared with anyone, saved in your disk or in any format that you way, in a standardized format. In other words, it's a standardized way to keep your key, derive your key, reproduce things easily. So it was proposed in the BIP32 spec. Here, if you see, what it says is, this is the first key. Here it says, this is the root key's fingerprint. From this root key, this is the derivation path I used to come up with this pub key. Then from this derivation path, I can finally come with the public key. That public key is the one that we will actually use it in the Bitcoin script, right? That's how we build. Bitcoin script doesn't understand this. It has no idea about the expub. It has no idea about the BIP32. It only understands 33-byte compressed version of pub key, or if it is taproot, 32-byte version of pub key, right? So, but we need, we know that in the wallet world, we are not, we put our seed phrase. If you already used any wallet, we put our seed phrase. From that seed phrase, at one point, this kind of version of BIP32 version of pub key is created, private key is created and stored in your wallet. That kind of thing happens. So that's what here represented here. Same for other keys. So this is a description. Sorry. So I wouldn't get it. TPUB. It says that testnet version of XPub. Yeah. Any questions in this? Okay. What it simply says, I can get it, share it with any wallet that does support descriptor. Immediately that wallet can understand and reproduce, monitor your transactions in the blockchain if it is monitoring the blockchain. Or if you have your private keys here instead of the public keys, we can place that as well. If you have your private keys, all of, I mean, let's say you are one of the signer, you have your private key here, then the signature for this private key can be produced easily.
I have two questions.
Yeah.
First one is that why does the order matter here?
Hmm.
You have like the first, second, and third keys, right? Can you switch them up, or does that make the
In this particular script, we can switch them, no issues, because it's a 2 of 3 wallet. Any two keys simply we says.
Sorted multi is the one in which you get switch off.
No, this is not sorted.
This is not sorted. Multi is not sorted.
Multi is not sorted.
Yeah.
So
So we can't switch the order.
no. I mean, in this example, I think he is asking about why in this particular example this is ordered in this way. If I put this in the beginning, yeah, I get the point that you are coming with. If he's gone. Okay, I thought I had some illusion. So for that question, if you create this, if you share with the co-signer, another signer is going to be one of the party, right? They cannot switch this. That is a valid question because the produced Bitcoin script will be totally different. The address will be totally different. They cannot switch this. There is some other primitive here. It's called sorted multi, the one that he mentioned. That will automatically take care of it by it starts using some ascending order, descending order kind of some kind of.
The second question is
That's not fair. I was talking to a child, teacher.
No, it's listening to it.
Yeah.
The second question is when I'm backing up my coordination data in a multisig like Blue Wallet.
Sorry, repeat.
Like if I have a multisig wallet using Blue Wallet or something. So and I back up some kind of coordination data, right?
What data coordination?
Yeah, I don't know what kind of file I have to back up.
To back up this?
I don't know if it is like I was going to ask if the file is the file contains this thing.
Okay. Yeah, you can take a backup of it, export this, and import it in any of your wallet if that's what you're asking. I didn't understand what you mean by coordinator. If somebody is getting.
That's what it is. You have your seed plus this.
Yeah.
You can't have just the seed and recover this.
So this is basically the backup data.
This is the
The
backup.
script can serve as a backup data.
It can serve as a backup data as well as in your wallet, it will be sitting.
So this is the standard.
Yeah, this is a standard. So we've seen the 2 of 3 for the descriptor example. So what is descriptor now? Sorry, we move to descriptor. Now you can switch back your mind to bring, okay, why we've seen miniscript kind of things in within the descriptor. Because descriptor is a separate BIP 380. It came one time. Miniscript came later, I guess. Okay. The miniscript people who wrote the miniscript spec, they made sure that it aligns with the descriptor because they both are kind of working for same purpose related to the Bitcoin scripts, right? Standardize the Bitcoin scripts. But the descriptor is something that can understand whether it is SegWit, not SegWit, taproot, those kind of capabilities descriptor has. And descriptor also has, it is the descriptor that specified this spec, how to represent your keys. Miniscript doesn't understand those kind of things. Miniscript is just a template, placeholder. But only descriptor define this. This is how you should specify your XPub details. That is defined by BIP380 descriptor. This is defined by descriptor. This undar is defined by miniscript. Older is defined by miniscript. After is defined by miniscript. This yes, those these are all defined by miniscript. So it's kind of, one person created one thing, cool. The another person creates something which works with these things. So he decided to let's combine this together, make it more usable, more standard, those kind of things. So that's why you see that's why we call it as miniscript plus descriptor plus miniscript or descriptor with miniscript. You can say in that way. Any questions here?
It's S, like you mentioned as S colon.
Yeah, this represents the opcode swap. We have op swap, which simply swaps the stack data. If you have two data, I think it swaps A, B. It takes a B and put B and A. It is, I mean, just because you have miniscript, you don't think that you are completely freed up from thinking using your brain. Okay, you still have to figure out your Bitcoin script. Your work is reduced, not completely eliminated. Please keep that in your mind. So you need to the reason why S is here is the developer of this miniscript decided to put it here so that actual valid Bitcoin script can be produced. Otherwise, if you remove this yes, this is not going to meet that condition that we are talking about because you simply wrote a invalid code. That's it. So you need to understand the miniscript's primitives, what kind of rules it has, what kind of primitives that provides, and you need to map that with the actual Bitcoin script world. Then you have to write it. It will enable you to not screw up further. That's advantage. Yeah.
Okay, so why not have the S on all the three keys?
Yeah, because in your let's see this. No. Do we have S here? Yeah, we have S here. So what does it say? Where is the swap opcode? Do we see swap? Yeah, OP swap. Okay, let's forget about the miniscript completely now. We are only living in the Bitcoin script world. You are writing a Bitcoin script. If you remove this OP swap, it means it's a broken code because this is actually a valid Bitcoin script, but you remove it or when you write it, you didn't consider to put a swap. I mean, when you
function of
swap, the function of swap is in stack node stack, right? The Bitcoin script stack. If it has two elements in the stack, AB, it takes a AB, it put the BA.
What? Why?
Because that is how this script will be able to meet the spending condition that they mentioned. That is specific to this script, something specific to this script, not general stuff.
I think it's common in like 2 of 3 multi-sig and all users, right? Whenever there's a n of m.
No, it doesn't use the OP swap.
No, why would it?
It doesn't use the OP swap.
So usually if you have
Maybe that is because of that condition
we have hand
after 19
Okay.
or April, whatever.
No, I think it's difference might be right because if gives a 1 or something as the thing and then you swap the 1 out.
Due to the time, I'm going to speed up a little bit. So in short, for that specific question, why yes, you need to understand why yes and write it in right way. That kind of lazy answer I'm going to give now and move on. So this is a descriptor that can understand by any descriptor based wallet. Now we are getting into the demo. If anybody is sleeping, please get up, demo. If you don't know coding, you can go back to sleep, in fact deeper sleep. What we are going to see in the demo, these steps. First, we will create a descriptor, dummy descriptor with our own made up rules, spending conditions, which uses one signature and time lock. And we'll create an address using that descriptor. And if you are familiar with the reg test, I mean running your Bitcoin node in a testnet kind of environment where you can easily navigate the blocks, mine and everything under control. So I'm going to run a reg test node in my machine. In that node, I'm going to mine some Bitcoin and that Bitcoin will be moved to this address. Okay, that is a one step. Third step, then I will create a PSBT. Okay, what is PSBT? PSBT is another standard which helps you to write, helps you to write and move your transaction with your cosigners and different softwares in a standardized way with all the required information. Like if it involves hashes, it will have a place to put your pre-images of the hashes. If you have keys, it will have a separate place to place your partial signature. If it has, who's that? If you have pub keys, export details, derivation paths, those things, it has a separate part to do. Everything in a single standardized format, in a binary format that can be, I'm going to look at you now. You have to wake up. So in a single standardized format that easily you can move in the network and store it in the disk, any PSBT supported wallets can easily understand this and cosign it. Okay. So that is the PSBT. We are going to create a PSBT transaction and this UTXO, right? We deposited to this address, right? It produces an UTXO. That UTXO will be added to the PSBT as an input and then create a change address. When we spend, sometimes we have the change address, right? So whatever the amount that we originally wanted to the outside world, outside output address, the remaining amount will be added to our change address. The change address will use the same descriptor because both are sharing the same wallet. Change address is nothing but the same wallet's another address, right? So that's what is mentioned here. And yeah, then sign and send the output address. That's it. And we will parse the PSBT using the descriptor easily because, yeah, that's the one thing. So all these three combined will become Powerpuff Girls. You'll be super powered mode. That's the thing. Okay. The example that I'm going to use, this is the spending condition. Simply, it has two keys, two conditions. One is the primary key can spend it immediately. The another one is after this transaction is mined, current transaction is mined. After 100 blocks, recovery key can start sign it alone. That is a spending condition. Any questions here? Okay. So this is the miniscript. The descriptor version of the miniscript is this. WSH, I'm going to use the native SegWit, WSH and the same stuff here, but we need to place the expub details here instead of this dummy placeholders. And this is the actual Bitcoin script it can produce. Okay, it meets that spending condition that I just explained. Okay. Okay, I'm going to use the Lightning Labs Polar tool, which enables us to easily run the Bitcoin node. So here I'm going to create a Bitcoin node now in a rec test mode. Let's give it a name. We don't want LND, Core Lightning, Eclair. We only need one Bitcoin core as our node. So it uses Docker and everything in the background. So it now I'm going to start it. So now a Bitcoin node is up and running in my machine in a rec test mode. This is that node. And okay. We need to mine 100 blocks to anything to work with, right? So first 100 blocks, it will throw an error. No, I got lucky. It's not throwing an error. So it's mining first 100 blocks from the Genesis. Now you can see the balance is increased, right? Now we have the node up and running and mined with 100 blocks, those kind of things. Sorry?
This will zoom, increase the font size.
I will screw it up. You try that.
Is this better?
Yes.
Thanks. So we have the CLI for that node. Now what is the first step? We have to create the Bitcoin script using the descriptor and create the address for that. For that first we need those two keys. So that we need those two expubs for those two keys. So here I'm using some third-party library called Bitcoiner Lab Descriptor JS Descriptor and JS Miniscript and we have done some wrap-up work around it because it has some bugs and it is not completely adhered to the spec of the descriptor 380. So we have some wrap-up around that. I'll come to that part later. But first we have to create the expubs, those two expubs, and for the to address we need to create another expub because we want to send to some third-party to address, right? We need to create another expub. So those things. So I already created the expubs. These are all the details. Using the above code, it simply uses the bit32 library, excuse me, all the libraries that is required. Sorry, all the expub and the derived keys that I've shown in our examples. Here key is the primary key, the guy who can immediately sign. The recovery key is the guy who can sign after the 100 blocks mined, right? So here, if you see the last part, here we have the expub, like it is the fingerprint of the root private root key. Here this is the root key. Then I use this derivation path 1 and 2 to come up with this to derive this expub. Then from this expub this is going to use 0 and any number, wildcard number, index values, right? In the expub in the index value, so it can be 0 1 2, usually that's how we do. So it's wildcard star here. So this is the expert bit32 expert information within for the recovery key. The same for the key, the primary signer. And I'm creating another one for the to address, some random address that we are going to send. I'm going to use this, and I'm going to use another descriptor for that purpose, a simple descriptor. It's P2WPK PKH. That one I'll come to that part later. Let's ignore that. So first showcase Miniscript capability with some functions that Miniscript usually provides. Okay. So I passed this. Let's ignore the policy now. It's just another wrapper around the Miniscript. You can say that, but ignore that. So let's assume that we passed the Miniscript here, and the Miniscript is written. It's simply saying it is sane or insane. I mean, it is a valid one or invalid one. And the actual Bitcoin script that the Miniscript can produce. That's what is going to be shown now. There is the output. Okay. Okay. So the Miniscript itself, and it is a valid one. This is the Bitcoin script it can produce. We only pass the Miniscript. Okay. It says it is a valid one. It will produce this Bitcoin locking script, and using these two unlocking script, you can unlock or spend your Bitcoin from this address. It says, since I used older primitive from the Miniscript, it is nothing but sequence check sequence verify. So that n sequence has to be set in the transaction input. So 100 is set here. I mean, your transaction input for this particular UTXO, the n sequence value should be 100. That's what it tells us to do with our PSBT. And then the signature that has to be added to spend, or you can simply put the keys, one key. This 0 is most likely for some bug reason or some other reasons. We can ignore that. So either simply said, either you can spend it using by producing this key, or this key and this transaction input in the transaction level data. So it says it is a non-malleable satisfiers. What does it mean? I mean, once the witness is produced with either of these two spending unlocking scripts, it cannot be modified and still become a valid witness. That's what it means. So that's the capability. It all deduced by itself by the spending condition. This is the spending condition. This is the spending condition. This is how you have to spend it. Everything is automatically deduced. You don't have to spend your mind to do that. It's up to that. You only focus on your yeah, we could say that if you use Miniscript, you can only focus on your locking script. The unlocking script is something that it will produce validly. That is another advantage. We can say that. So now we've seen the Miniscript. I just copy pasted these pub keys to this Miniscript and made it a descriptor, the same one whatever we've seen. So this is the descriptor string, and this is the private key of the recovery key signer, the party who can sign after the 100 blocks mined. And this is the to address descriptor, simply segwit P2 PKH, segwit PKH. It simply requires one xpub to produce one pub key. So now let's create the address. Here we are validating the descriptor to whether it is matching descriptor based rules or not. Then I'm using that libraries function to create a object which has all the functions to do all the requirements, that functionality that you require out of a descriptor. So descriptor, if you provide a descriptor, it will automatically give you the address. Okay. And I'm using the index value 0 for those 2 stars, the wildcards. So I'm going to run this. So this is the address we got. We are going to send some Bitcoin to this address, and then we will try to build a PSBT to spend from this address. Okay. So copying it. Sorry. Going here. We want to first, since our node doesn't know about our wallet, I mean our descriptor, right? That is one thing. the descriptor is something that we are building using our library internally in my machine. This rectest node doesn't know about the descriptor, so we have to create another wallet in the node, our own wallet, and feed the descriptor to the Bitcoin node, core BTC. Okay, so it uses the descriptor to start monitor the transaction that comes to this descriptor, produced addresses, produced transactions, those kind of things. That's what we are going to do. In short, we are going to use our descriptor and create a wallet in the rectest node. So how do we do that? Yeah, we are going to do this by doing the lazy work. Let's ignore these commands. It simply creates a wallet in the node. Yeah, our own wallet. And now we are going to import our descriptor. If you had any questions, what do you mean by importing the descriptor to a wallet, hardware wallet, or your node? That's what we are doing here. Here, simply saying import the descriptor to our wallet. This is the descriptor, and start monitoring from now. Any transaction comes or goes, and the index range values, some kind of things. We can ignore that. Not important. So I'm simply using our descriptor. I import the wallet. So now the Bitcoin rectest node start monitor any transaction that involves using the addresses created by this descriptor will be easily monitored and tracked. So we have our own wallet in the node itself. That's a summary. Now we are going to send some 5 BTC to our address. Is the address same? Yeah, 3DA. So one transaction is done. We deposited 5 BTC to our descriptor produced address. This is the transaction ID. And now we need to get some data from the transaction to build the PSBT. Shit. That's why we should not copy paste. Shit. Transaction. I'm going to get the fetch the transaction details. True. Yeah. True. Now what we are seeing here is from the node default wallet, we send some Bitcoin 5 BTC to our descriptor based wallet. That transaction is decoded here. This is the transaction hex, and we can see that transaction done to our address. What is our address here? This, yeah, second one. V out one is our transaction. This one, okay. So now I'm going to take this transaction full hexadecimal and going to code, paste it here. So now PSBT construction part, we are creating an PSBT object. We are using UTXO, the transaction input. We know the V out is 1, right? The second one, right? It is not 0th, it's first one.
0, 1. Oh, we have 0.
No, 0 is 44 and 1 is 5.
So this is us. Which one is us?
Scroll down.
Second one. Yeah, 1. V out 1. So from this UTXO, we are spending, sorry, from this transaction, we are spending the first indexed output, and the output is 5 BTC, and arbitrarily I'm choosing 3 BTC as the spending amount, and I'm choosing 10,000 sats as the fee, and the change amount that should be coming back to our descriptor wallet. Okay, whatever that amount that is going to be there. So what we are going to do now, okay, what we are going to do now, so I told this is nothing but the private key, the root private key of the recovery signer after 100 blocks. So I'm creating the BIP32 object and using the same derivation path to derive the ultimate public key that will be used in the actual Bitcoin script. Okay, so we got the public key that should be used in the Bitcoin script, or that is supposed to be used in the Bitcoin script. So now it is the kind of important part. What you are passing here is the descriptor string, first index, the 0th one, because that's how we created the address, and the reg test environment. Ignore this. And we are simply saying this is the public key. I'm going to give it to you as a known variable. So with this known variable, you tell me which spending path I can spend. That is what we are giving here. Here we are giving the recovery key signer. Now descriptor and miniscript is supposed to give us, this is the spending condition you are going to spend. This is the unlocking script. Those kind of information you can easily understand out of it. Okay.
Based on the key provided.
Yeah, based on the key provider. We are simply indicating that this is the key I know. For this key, I have the private key. Now you tell me which spending path I can sign. You tell me the cost. You tell me everything. I'm going to be the lazy person here. It will take care of everything. That is a goal. So then, yeah, we are adding this into the PSBT, this input. Simple one function called update the PSBT as input. It does bunch of work in the background. And we can easily calculate the input cost. And we are going to do something similar to for the to address, simply getting the to address here, adding it as output to the PSBT and showing the output address cost, output cost, and the change address. We are going to use our same descriptor but a different index value if you notice here. As a change address, I'm just using index value 5.
Why not the next subsequent?
We can do that. I just put 5, my favorite number. I just like. So change address. We are printing here and we are again adding it to our PSBT as another input. So 2 inputs, 1 output, that's the case. No, 1 input, 2 output, that's the case. One of the output is our change address. And the cost of the change address, and we are going to sign it with the root xpub of the recovery key signer and validate whether this PSBT valid or not by doing the schnorr signature, passing the schnorr signature function here. Yeah, then find. Yeah, elliptic curve only. This verifies schnorr verification. It's simply going to do the schnorr verification. This function is alone. It's a schnorr verification function. Yeah. Yeah, we are going to finalize the PSBT, extract the network format transaction, have it in a string format in hexadecimal. That's it. That's the code here. Please, it's going to be end. Don't worry about it. We are almost close. We started monitoring our wallet, right? We created the descriptor already.
We did create, we are not monitoring.
No, that should imported. Yeah, I think. Let me check. Yeah.
We should check that.
Yeah, let's check the balance. Yeah, right. So before we do anything here,
It already showed check the transaction.
so you can see the 5 BTC that we in the pending state, so we should mine it. Since we now have 2, okay. Yeah. So I'm going to mine for 6 blocks. Oh shit. So I'm simply doing mining to mine our transaction. Now check the balance again. It is in the trusted section, so it is completely mined now. Then what else? Mined it. We check the balance. Now we have to take our transaction and paste it here. So we are going to broadcast our assigned transaction with the recovery key. And we got error. Why do we got error?
Because 100 blocks, we have the
That's the reason. Yeah. So we are not yet 100 blocks mined from the transaction got originally mined. So we have to do the 100 block mining. So I already have the command for that. So it's mining 100 blocks, 101 blocks. Yeah, we mined 101 blocks. Now I'm again going to. Yeah, the transaction is success now. We were able to build the PSBT and now we broadcasted the transaction. It gives something else. what now we need to double check. So we mined, we broadcasted la. We need to check our balance again to double check that we really did what we were going to do. Yeah. So finally, you see the balance is updated. The spending amount minus the change amount minus the fee. That's what we are seeing here. That's it. Now, these are the links. Any questions? I know half of you went to talk, some of you went to sleep. If you are still awake, any questions? So I was right. Yeah, we are done. Thanks everyone.
Thank you.
Should I